Over the past 70 years or so, one of the biggest questions facing science has been, where are all the aliens? We know that planets exist out there that could be home to intelligent life that are capable of communicating with technology, and yet we haven't found anyone. Well, what if I told you that one possible solution to the so-called Fermi paradox implies that humanity is literally the first intelligent life to exist? It seems crazy, but there are some very convincing arguments in favor of it. Now, before we get into humanity's place in the universe, I'd appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so in order to answer whether or not we might be the universe's precursor life form, we need to talk about two key points. One, why the universe could be so hostile to supporting life right now, and two, what could cause conditions to improve in the distant future. So to start, how bad do potentially habitable planets have it right now? Well, if you think about it, there is quite a lot going against a planet that is trying to grow and sustain a biosphere. You see, right now a significant percentage of stars in the universe, about 1 in 100 or so, are massive stars that burn through their fuel quickly, expand to become gigantic stars, and then implode on themselves to create brilliant supernovae. The issue with these stars for sustaining life is twofold. One, these stars only live for about 10 to 15 million years max. This is a problem because if we use Earth as a reference, it takes way longer than that to get the conditions just right for life to develop. As far as we know, microbial life didn't develop on Earth until it was about 800 million years old, and complex multicellular organisms needed 4 billion years before they really took off. In addition, these stars burn so bright and hot that their habitable zones would be several times further from the star than Pluto is from the Sun. These things together mean that massive stars are already quite inhospitable when they're alive, but it gets worse when they die. This is because when a massive star goes supernova, the explosion alone is enough to sterilize planets up to a 100 light year radius, which could very well include less massive stars that host planets that would otherwise be habitable. That's bad enough, but there is a very special type of supernova that is only produced by the very largest stars that can have even more far reaching impacts, a gamma ray burst. In these explosions, jets of extremely high energy gamma rays will explode from the star's poles, and these beams are so powerful they can have an impact on planets up to 8,000 light years away from the original explosion. Luckily, the beams themselves are quite narrow, so a planet would need to be pretty unlucky to find itself in the path of one at any given time. However, the combination of regular supernovae and gamma ray bursts can make certain galaxies, and even certain regions of our own Milky Way, very inhospitable if they have a higher density of high mass stars. To make matters worse, these high mass stars were even more common in the past, and in the very early universe, they were pretty much the only stars that existed. It is estimated that the universe may have been inhospitable to life as we know it for the first 8 billion years of its existence or so. And given that the universe itself is only about 13.8 billion years old right now, that's essentially 2/3 of the universe's present lifespan that is off limits to the development of life. Even today, it is believed that only a fraction of galaxies are able to actually support life due to inhospitable stellar densities, and even those galaxies may only support life on their outer edges where stars are less dense. In addition, any planet that does form in these regions needs to avoid other factors that may hinder the development of life, like asteroids, the activity and characteristics of their own star, or rapid ecosystem destabilizing climate change. Even our own Earth has dealt with these disasters, with multiple mass extinction events having happened in the past. But it is still, to our knowledge, the only planet that has been able to overcome everything that has been literally or metaphorically been thrown at it and still have a thriving biosphere. So, with that being said, why could things be better in the future? Well, there are once again two reasons for this. First of all, it stands to reason that life has only really had a chance to exist in the past 6 billion years, and Earth needed 4 billion years to really get going. The window for life to form has been narrow to start with, and more opportunities will arise if we even let a few more billion years pass. But a second, far more compelling reason exists, and it has to do with the fact that the universe is still, relatively speaking, very young. You see, it is 13.8 billion years old right now, but stars are predicted to keep forming for 100 trillion years, about 4 orders of magnitude longer. What's more, as the amount of available gas to form new stars decreases, the population of stars will increasingly be made of dim, low-mass red dwarf stars similar to Proxima Centauri, the nearest star to Earth. These stars may possess a couple of key advantages that other stars don't have. Our Sun is a great star, but it is predicted to only last for about 5 billion more years before it dies, giving about 10 billion total years for life to develop. While it clearly worked on Earth, It is very possible that that simply isn't enough runway for most other planets. By comparison, the red dwarf stars are expected to themselves last for trillions of years, with the absolute lowest mass stars currently estimated to have a lifespan of about 12 trillion years. What's more, red dwarf stars don't explode in fiery supernovae. In fact, they don't even swell to become red giants like our own sun. When they die, they kind of just flame out and become white dwarfs. This means that a universe full of red dwarfs would be far more stable and potentially hospitable to life. And if life did develop on a red dwarf, it could continue uninterrupted for a long, long time. As such, this is the kind of situation where you might expect life to crop up all over the universe, with potentially a significant proportion of stars that have planets in the right position having full fledged civilizations like ours, or maybe even greater. Who knows? Maybe it's the case that Star Wars doesn't take place a long, long time ago, but rather a long, long time from now. Of course, there are a couple of major caveats to this theory. First of all, the entire theory is based on the assumption that since we have found no evidence of life beyond Earth, we may be the only life that exists. However, the fact that life has been able to develop on Earth all means that our universe as we see it today is still somewhat habitable. And given how there are billions of other stars in our own Milky Way alone, it seems quite likely that if life could develop here, it has probably developed on some random planet like 70,000 light years away as well. It may not be common, hence why we haven't found anything yet, but that doesn't mean they don't exist. But another key problem with this theory lies in the fact that we still do not know how hospitable red dwarfs actually are. The thing is, the vast majority of the red dwarfs we found are very active stars, emitting powerful stellar flares that could deal major damage to a planet's atmosphere with relative frequency, even compared to our own sun. There is some evidence that the older red dwarfs may be calmer, but by that point, the damage may already be done. It is very possible that any potentially habitable planet that forms around a red dwarf has its atmosphere relentlessly attacked in the first few billion years of its existence, and by the time its parent star calms down, it is nothing but an airless husk completely exposed to outer space. Even if a planet manages to hold on to its atmosphere, life may be stymied by something else: tidal locking. Since red dwarfs are so small and dim, a planet has to orbit very close in for it to have a chance of having an Earth-like climate, but in doing so, tidal forces from the star will cause the planet's rotational period to perfectly sync up with its orbital period. This results in a situation where one side of the planet is permanently facing the star, resulting in eternal day and thus scorching hot weather, and the other side is always facing away, locked in the everlasting chill of night. On these planets, the only place where life could be found is in the narrow twilight zone between the two halves, which may have a much more temperate climate. It would be a tall task, but given space to do it, life could still very well find a way to exist in this region. This is a lot for a planet to live up to, and as of yet, we have found no instances of a planet actually harboring life in this way. But if we venture deep into the future, where red dwarfs are all that are left, all it would take is for some planets to hold on to their atmosphere during their volatile early phase, and then it would just be a matter of time. Which again, red dwarfs have about as close to unlimited time as it gets. So ironically enough, even as the universe is slated to get colder and darker as the eons pass, the future for life may just be as bright as ever. And that's all I have to say about life in the universe. As always, I appreciate you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.